Hello everybody, I'm Nick, and in this video I'm going to show you how you can implement simple, reliable scheduling in .NET with the minimal amount of code. And I am personally more of a cloud native person, so the solution I'm going to be using today is utilizing the cloud. However, you don't have to worry about cost and pricing. This is a very cost-efficient solution to the point where unless you're doing millions of scheduled events, you won't actually even pay anything. It is part of the free tier of AWS, which is the sponsor of this video. So this is focusing on small, simple scheduling, something like sending nightly emails, maybe rehydrating some cache, maybe some background tasks that you want to run, I don't know, a few times over the day. So this is the type of scheduling we're going here. Many of you might be familiar with Hangfire as a scheduling tool, and I have tons of experience with it. I have an even better alternative than Hangfire, which I think is significantly better actually. That more grandiose, we're gonna see in a different video. Here we're gonna focus on simple scheduling, and we're gonna do that all in AWS, who is also the sponsor of this video. So all the code for this is free for everyone in the description, and everything I'm going to use is part of the free tier. So you can just grab the code and run it. You don't have to pay anything unless you're doing millions of scheduled events per month, and even then you're paying $1, less than $1. So it is very, very cost efficient. So let's go straight into the solution. If you like the type of content and you want to see more, make sure you subscribe or ring the notification bell. And for more training, check out nickchapsas.com. So like I said, we're going to be using AWS here, and we're going to use two services to implement this. We're going to use AWS Lambda, which just added support for .NET 6. So all your .NET 6 code is applicable here and usable. And also we're going to use AWS EventBridge, which will allow us to do the scheduling part. So because it's AWS, we need to first install a few tools for our command line. So first I'm going to use the .NET tool install G, so global amazon.lambda.tools, which will allow us to install the Lambda tools on our global environment here. So I'm going to do that, and this will quickly install that for me. And then because I also want to have templates to create my Lambdas, because I don't know how a Lambda project should look like, then I can go ahead and use .NET New I amazon.lambda.templates, and this will install all the templates for Lambdas. And this is the latest 6.0. So we have a bunch of them. We're going to use one of them. You're going to see which one. The last thing we want to install is a tool that allows us to test our Lambdas on our local machines, which gives us a very nice developer experience. We can just debug the code and all that. So that is the command for that. We're going to use a 6.0 version. Now, if you had used AWS in the past, you don't need to install those tools. You just need to update them. So with all that installed, I'm going to go ahead and create a new project, and I'm going to scroll all the way down and use the Lambda empty function over here. And I'm going to say simple scheduling.lambda here. So I'm going to create my project, and the project actually comes with a test project as well. Now, we could talk about how we can test Lambdas maybe in a separate video, but the developer experience for that is also pretty decent. But for now, I don't really care about that. So I'm going to remove it from the solution and only keep what I have here. And now this generic Lambda, if we go into the function.cs, basically has nothing. And what we need to deal with is some payload that triggers this Lambda in a given moment in time, and then we do something about that. And this is basically your scheduling. And then in here, you can use any package that you want. If you want to use Mediator, if you want to use any package, everything is applicable here. And this is effectively your entry point. Now, the question is, what will actually trigger this Lambda? What will say that at 12 a.m. today, something will trigger this Lambda and will say, make this action? Well, this is where a service called AWS EventBridge comes into picture. We can create a rule, and we can say that nightly or every midnight or every o'clock, do something, trigger this Lambda based on that rule, and maybe give me some payload as well, because I need to act on that. How do we do that? Well, let's go into the AWS console first. So what I have in front of me is the AWS console. And if I go into Lambdas and EventBridge, you can see I have 0 Lambdas right here. And I have no rules in EventBridge. Now, what I need to do in EventBridge first, which is effectively an event bus that you can use for way more other things than just that, we're just going to use one feature here, is we're going to go ahead and say create rule. And we're going to call that, I don't know, mail Patreons or something. Maybe let's say I want to mail my Patreons and I want to do that every week with a newsletter. I don't know. And we want to go with schedule here. So we want to do that at either a fixed rate every minutes, hours, days, or we can have a cron expression, which, if you don't know what cron is a way to define either time-based execution or time in a fixed rate execution. So let's say for every half past or every 15 to. So it is basically a way to define time. And if I go here and I actually fill this in with the suggested cron expression, so I think it was that, and this. Did I miss a star? I did miss a star. What this basically means is this rule will be triggered every 5 minutes in this case. So the next 5 minutes, then 55 o'clock, 5, 10, 15, and so on. You can use online cron expression calculators to actually generate this for you. It's the same pain in the as regex, in my opinion. Actually, regex is worse, but it's a very flexible way to define an interval or a time-based trigger. So we know that, and I'm not going to do every 5 minutes. I'm going to do every 1 minute. And the reason why I do that is for test purposes. Now, what I can do is I can expand this sample events thing over here. And this shows me what the event that my Lambda will receive will look like. So it has a version, it has an ID, it has a time when that event was sent, region, and a bunch of other metadata. And then it has an empty details object. There's a way to populate this details object, but in the current form of EventBridge, you will miss out on the rest of the data. So it really depends on what's important for you, which is absolutely fine, by the way, because if you follow a more like single responsibility approach, you can have one Lambda per scheduled task. So you can have one rule pointing at a single Lambda, which is great because then it means you don't need a body. However, if you do need a body, there is a way to configure that, and I'm going to show you that as we go. And then we come down here, and yeah, that's fine, enable it. And then we have to select a target. Basically, what should EventBridge notify with that payload, what it should call in the cloud. And in our case, this is a Lambda. So we want to point at a Lambda function. Currently, we do not have a Lambda function, but me showing you this will put everything in context when we deploy our Lambda. We can configure a version and an alias if we want to. We can configure the input, and this is where you can actually define your own custom event text. So you can have like action, and then this can be email Patreons, and then I can create another rule as well, and it can have a different action name, but I don't care. I'm just gonna have a matched event, but this is ultimately up to you. You can choose to go either way. The reason why you might want to go with the constant JSON text is because you might want to have multiple rules pointing at the same Lambda, and then based on that text or that JSON object, you route to different actions within your Lambda. So let's say I'm gonna email this bunch of people here, and then I'm going to have VIP email if statement or switch statement internally that calls a different path. And that's it. And now, obviously, I cannot create it because I don't have a Lambda to call, but now I can go back to my code and show you how I can implement the handling. So if I was to just match the event and I don't care about the actual object, the JSON text in the middle, then all I need to do is go in the dependencies and find the NuGet package, and I'm looking for the amazon.lambda.cloudwatch events. The reason why it's called CloudWatch is because it used to be called something, then it was renamed, but the SDK is still named on the old thing, so that's why. But if I install that, what I can do is go here and use the CloudWatch event, and because I don't care about the actual object internally, I'm just gonna call this object. I don't really care about this type. This is ultimately the empty details object that you saw in that body. And then if I go ahead here, I don't want to return a string. This can be an async task, by the way, and be awaited if you have some IO operation that you want to run here. I don't really care about that because I won't be emailing anyone. So I'm going to turn it to void. However, I'm going to log as part of this execution so I can show you what this looks like. So I'm going to say context.logger.log information, and I'm going to say received call at, and then I'm going to use the input object. And if you see here, the input object has the account that called it, the detail object, which in our case is empty, the ID of the event, the region, the source, the time, the version, anything. I'm just going to go for the time here, and I'm just going to print that in the console. This is where you'd implement your own logic. So this is my Lambda. Let's say I'm happy with that. All it's doing is logging something in the console, but if this was a real Lambda, it could be doing some job, and that's where that job code would go. So the way to deploy this very easily is using that tool that we installed, the Amazon Lambda tool. So to deploy this, and my machine is already authenticated against the cloud, so I don't need to authenticate in some way. All I need to say is .NET Lambda deploy function, and then I'm going to select the region, and in my case, it's the London one, so West 2. And that's it. I'm going to call that. It's going to ask me a few questions. For example, how do you want to call this? I'm going to call it, what did I call the thing? Patreon mailer. Let's call it that. So I'm going to give the Lambda name, and then I need an IAM role, which will allow the Lambda to have access to what it needs to do. For example, if it needs to access DynamoDB, or if it needs to access the emailer, I'm going to have a role that has access to those things in the cloud. That's why security works. So we're going to call that Patreon mailer underscore role here. And we are going to go and attach some roles to that policy. Now in here, I'm going to go with a basic execution policy, but I'm going to modify that even further. So my IAM role is being propagated now to all the regions in the cloud. And once that's done, I won't have to specify that again. It will detect it by name and just know. And as you can see, my Lambda now is created. And if I go back here and refresh the console, as you can see, I now have one Lambda function, my Patreon mailer, and I want to go here in the configuration and change the roles a bit, the permissions. So this is the IAM role we created. So what I want to do here is attach a couple of permissions. So I want the AWS Lambda role over here. So attach, and also the Amazon Event Bridge, so we can actually access EventBridge, and we want the read-only access over here. So I'm attaching those two policies. That is fine. So my Lambda is now running, and now I can go back to Amazon EventBridge, and it obviously cannot detect the Lambda automatically. I'm gonna refresh this and recreate it. So Patreon mail, here we go. Schedule, like I said before, 0, 1, ****, question mark, star. Whoops, that goes here. So every minute this will be getting a call, and I'm going to configure this to point to the Lambda function. And the function is the Patreon mailer. And that is it. Now here you can even configure retry policies. So for example, if the processing fails, you can retry n amount of times, by default 185 times. And if that is exceeded, then you can actually push to a dead letter queue, and you can investigate further why was that event not handled, what went wrong. So I'm gonna go ahead and create this. Now every 1 minute, this will be getting called. The minute just changed. So what I'm gonna do is go back to the mailer, and I'm gonna go to the monitor tab, and I'm gonna view the logs in CloudWatch. So CloudWatch allows me to visualize the logs for that service. As you can see, the service was triggered to the T on the time that I specified. So no cold start worries with the .NET 6 implementation. You can see that it's getting called, and it says received called at that time, which is exactly when we wanted. And if I wait for 1 more minute, this will keep getting called. And you can see duration, execution time. In fact, you can see the cold start effect here. This is the first time this Lambda was ever executed, and it took 220 milliseconds to warm up. Now I'm gonna wait for the second execution too, which should have happened now. And if I refresh, we should see it any time now. CloudWatch takes some time to send the logs, but it should be significantly faster. So as you can see, there was no initial time because there was no cold start, and it only took 25 milliseconds to trigger that thing. So it's very efficient, very fast. It's very cheap. It's basically free. Lambda has a free tier, and then it's basically for every 1 million executions you pay some pence, and then EventBridge is the same. For 1 million executions, I think you pay $1 or so. It's something very, very small, but this is the simplest way you can just build it, deploy it, and forget about it. You don't have to host something. You don't have to build a service. You don't have to worry about anything. In fact, to prove you that this was all running for free, I can go back to my AWS cost explorer, which shows you the cost over time. And I started experimenting with this on the 28th of February. This is something else I was doing. So for the past few days, this was deployed, this was running, but as you can see, I wasn't charged anything because there's nothing to charge before. Now, remember when I said that you might actually want to customize the payload of that object? Well, if we go back to the EventBridge rule, and I select here and choose edit. Well, what I can do is I can say configure target input. And instead of matching the event and sending the body that you can see over here, this JSON object, what you can do is you can inject your own JSON text and then consume that from the Lambda. So for example, what I can say is action name, and this can be Patreon mail, something like that. I'm not going to, in fact, you know what? I'm going to save it. I know that once I save, the Lambda will start failing because it won't know how to handle this new thing. You shouldn't change your Lambda like this realistically. I'm just demoing this different approach. So I'm going to update that, and knowingly that the Lambda will fail, I'm going to go back to my code. And now instead of handling this CloudWatch event object, what I can do, I'm going to create an example class here. So I'm going to say public class event info, and this will have a string action name, which matches the JSON object I created in that rule. So let's say that I want to handle that event info. All I need to do is replace that object with this, and that's it. And now all you want to say is, realistically, you might want to use an enum for that, but I'm going to switch on the text. And let's say that if this is Patreon mail, and this has to be case, of course, then do something about it. And we're going to change and say received call for, and then input dot action name. And obviously this should switch on the action name, and we can break here. So break, and then default and say unknown action, something like that. And now that we have that, why is it not compiling? Because I don't have a break. Here you go. And now I can run the same code, so I can redeploy that. And I just need to provide the name now of the Lambda. I could provide it as part of the command, by the way, as well. So updating code, this is how easy it is to deploy using the tooling. And now this is deployed. So if I go back to the CloudWatch events, this should create a new folder over here. I have to wait for the next minute. I'm just going to cut to that point. So the minute is now passed. So if I refresh that and refresh again and again, hopefully I'm going to see the change. Here we go. So this is now created. And as you can see, received call for Patreon mail, with Patreon mail being processed by the input.action name from that object, which is the object we have in this rule over here. If I scroll down, it's this. What does that allow us to do? Well, what this allows me to do is, if I have like small code and I just want to have one Lambda that does sort of the same thing, but with a bit of variation, like I said, like premium Patreons, or Patreons who spend more than $50 with me, and I want them to receive like a special mail, I can go back to rules and I can create a new rule. And let's say VIP Patreon mail. So I'm making another schedule for that Lambda. And let's say I want this to run every 5 minutes. Here we go. Hopefully this is correct. Yeah, so every 5 minutes, I can specify Lambda here, and I can have it pointed at the same Lambda. So I can have multiple rules pointing at the same Lambda, and then filter within the Lambda what I want this action to do by providing a custom action. So let's say VIP Patreon mail here. Now, if I do that, this will go to default because nothing handles that thing. And in fact, I don't want to do it every 5 minutes because I'm going to have to wait for 4 more minutes now. Let's say 1 more minute. And if I create that rule and wait for the next minute to pass and go back to CloudWatch in the meantime, and let's refresh that. So the minute has passed. So if I refresh that and go back here, you can see that info unknown action. This unknown action is the one I just added. What you would do is you would go to the code here and say case VIP Patreon mail, and you will handle that appropriately. So you would send a different email for VIP Patreons. So the design in here is completely up to you. You don't have to do this. If you want to have one Lambda per rule, totally fine. If you want to have a mix, totally fine. You can point to the same Lambda from multiple rules, and you can customize that object too. So you have a lot of flexibility here. And again, like I said, if this fails, it will retry automatically. So you don't have to add any code for that. And if the retries are exhausted, then you can push that to an SQS queue and then process that queue to see what happened there. So it really takes care of everything for you, and it gives you the very interesting thing, which is just the code to deal with. And it is my absolute favorite way for simple scheduling like this, because I don't have to worry about anything. It's cheap. It's basically free. It is automated. It is managed. I don't have to worry about it. I only have to worry about it when things fail. And if something fails here, it will be my code. So Absolutely love that. In a future video, we're going to take a look at how we can do more complicated scheduling. This is more of a basic scheduling approach, but it is something I am personally using right now for my own projects, and I'd like to show you how you can do it too. So here you go. Again, all the code for this is in the description down below. Now you might be wondering, hey Nick, how do I test this? Because it's fine when it's deployed, but what if I want to debug it locally? Well, it's actually quite simple. So to do that, you want to go and create a new configuration. So I'm going to say edit configuration, and I'm going to add a .NET executable. And now we installed, if you remember, that test tool command. So if I clear that and I go all the way back, you'll see that we installed the Lambda test tool 6.0. So we can point to an exe path that this thing installed, and this will allow us to debug the program over here. Now, the way to locate this is in your user folder, you have the .NET folder, the tools, store, Amazon tool, and you want to go all the way and find the Amazon Lambda test tool.blazor tester.dll. And yes, they're using Blazor for this UI of this application. And once you have that, you want to point to your working directory, which in our case is this directory over here where the code is. And once you do that, then you can simply press debug. And let me just add this over here, and I can debug this code. And this will actually spin up a whole interface on my right screen. Now I'm going to bring it over here. And what this UI does is it automatically points to things like the config file, the function location, the profile, and I can specify the region as well. And then what I can do is I can select this drop down over here, and I have any type of trigger I might ever want. For example, SNS, SQS, message, S3 delete, S3 put, and I have scheduled event here as well. So I can go here, I can edit this with action, I don't know, action name, and I can say some action, so an unknown one, and I can step through the code if I want to, and it actually hits the breakpoint, and I can step through the code. It's an unknown action. It will print it to the console and then exit. And if I go back here, I can even see the log output for this Lambda and save request. So this allows me to play around with this in a local debuggable environment. And I also have a dead letter queue if I need to investigate and monitor how that goes. So it's a very nice, neat tool. That's why I showed you how to install it in the beginning, because you might want to use it for local purposes. So to wrap this up, this is my absolute favorite way to deal with simple, reliable scheduling in .NET, especially with the .NET 6 support that they just added. So absolutely love this. I highly recommend you give it a go. Just play around, see what you can come up with, and maybe even see how you can extend it. Well, that's all I had for you for this video. Thank you very much for watching. Special thanks to my Patreons for making these videos possible. If you want to support me as well, you're going to find a link in the description down below. Leave a like if you like this video, subscribe for more content like this, sharing the bell as well, and I'll see you in the next video. Keep coding.